Hi everyone. Today we're going to start learning about solving trig equations. So before we can start jumping right into these trig equations, we're going to learn about something very useful called the unit circle. So the way the unit circle works is we're going to be drawing a circle, hence its name. This circle is going to have a radius of 1. So then that means that the circumference will be 2 pi. This will be very important to remember. Now, the reason that we need this circle is because when we're solving for trig equations, we'd like to know where each of the points are around the circle. In order to do this, we need something called radians. And now, radians are represented with this here, which is the Greek letter theta. Now, what radians are is they just tell you how far you are along the unit circle when you start from a certain point. So you're always going to start from this point right here, and then, so this point will be 1, 0, obviously, and the way to see how many radians that is well, you haven't moved from that point. So that means that since you haven't moved, then it'll be 0 radians. And you don't need to put a label after that, 0. 0 is just fine. Then now, when you go up here at 0, 1, 0, 1 is 1/4 of the way around this unit circle. And now, the way to figure out how many radians that is I'll write it down here, is you would take the circumference, which is 2 pi, and then you would divide that by 4 because you're 1/4 of the way around, which you could then simplify that to be pi over 2. So up here would be pi over 2. And now over here you would have halfway around the circle. So what do you guys say would be the radians at that point? Yep, exactly. It would just be pi because that's pi over 2 divided by 2. Now you might notice a little pattern starting to form. Now, what do you think about right here at this point? Yep, I heard someone in the back say it. Exactly, it'll be 3 pi over 2 radians. And then let's say you go the entire way around the circle. Well, then that would mean that you have gone 2 pi radians. So now, might seem like a little bit of a problem because you've gone around the circle once, and so then that means that 2 pi and 0 are, there's multiple radians for the same point, which that's going to happen with all of them. Like, let's say you go around again here, then you'd get 5 pi over 2. And let's just say you keep on going around the circle. If you go around the circle twice here, at this point, you'd get 4 pi. 3 times, you get 6 pi. And you'd keep on going and going. So the way we solve that problem is we're going to look at radians from 0 to 2 pi. And we're not going to include 2 pi, but we will include 0. The reason for that is just because 0 is easier to work with. So now, let's say we get some random point on this curve P, which is made up of x and y, and it's at the point, or it's some theta distance along the curve, or the circle rather. So now you can use this to solve trig functions. Now there are 6 trig functions. The first of these is sine. And now sine of theta will always just be y. The next one is cosine of theta, which will just be x. And then the last one out of these 3 is tangent, which will be y over x. And now, And there are also 3 other ones that will just be each of these, or like 1 over each of these. So now the first one of these will be secant, which will be 1 over y, which is just the same thing as 1 over sine. And then there's cosecant, which will be 1 over x. And then the last one is cotangent. And now what do you guys think that cotangent would be? Right, it would be x over y. So now, and these variables x and y, like if we wanted to find like sine of theta, this y would come from this point P. So then, like, for instance, if you're at 0, theta equals 0, then you would just take, like, for sine of theta, you would take y as 0, and it would be 0. And then for cosine of 0, then that's x is 1, so you could take it, so that would be 1. Now let's do an example here. So now, let's say we have p equals 0, 1, which we had said was theta equals pi over 2. So now, if we were look at, actually let's do cosine first. So now, for cosine of theta, what you would do is you would take x, and now we have x equals 0. So, perfect. And cosine equals 0. And now, let's also look at cosecant of theta next, which would be 1 over x, and then we said x is 0, so then we 1 over 0, but we have a little bit of a problem here, because we can't do 1 over 0. So, in this case, we would just say that it's undefined and it does not exist. So, I'm going to give you guys a minute, and I'm going to have you guys find the sine, secant, tangent, and cotangent at this point. Alrighty, it's been about a minute, so let's bring it back in. So now, we'll just go over we'll go over sine together first. So now, what did we say that sine of theta would be? Yep, that'll be y. And then what is y in this case? Exactly, it'll be 1. So sine of theta in this case would be 1. And now we're just going to have you guys shout out the rest of them. So now, what would secant be? Yep, that would be 1. How about tangent? Oh, I'm hearing a few different answers on this one. So now, I heard a few people say it doesn't exist. For those people, did you get this? Yeah, exactly. Once you get this, that would again not exist. And then what we get for cotangent? Yep, that would be 0. So now, let's say we get to a point where we have something like theta equals, we'll just say pi over 4. Which it wouldn't be one of those nice ones that just has 1 and 0 in it. So, one way to think about this is pi over 4, it's about halfway in between 0 and pi over 2. So it'll be right around where I conveniently drew this line. So the way that I would recommend doing this would be making a triangle like this. Then I'll just put the triangle over here. And now this triangle will be a right triangle, not drawn to scale here, but now since we know that pi over 2 is, or pi over 4 is about half of pi over 2. Actually, it is half of pi over 2. And now the angle of pi over 2, what do you guys think that angle is right here? Yeah, that's 90-degree angle. So now what do you guys think then the angle right here would be? Exactly, that's 45 degrees. So right here will be 45 degrees, and that means that right here also has to be 45 degrees. And we've got ourselves a fun little 45, 45, 90 triangle. Yeah, I hear the groans already. But once we do this, it'll be easy. So we said that the radius will be 1. So that means that since this here represents the radius right here, that would be 1. And each of the sides here would be square root of 2 over 2 and square root of 2 over 2, as you learned way back when in high school geometry or whenever you learned it. So since we got this point from here, and this side represents here, and this side represents here, so that means that we have this side will be y, and this side will be x. So just like that, we have everything we need to solve for our trig equation, or each of the trig equations. So since we're running low on time, we're not going to do that right now. I'm going to have you guys do that for homework. But like for instance, you would just do the same kind of thing. Like if we were to do sine of theta in this case, well, that would just be y. So that would be square root of 2 over 2. So I'm going to have you guys do 2 things for homework. First off, I'm going to have you guys solve the trig equations for, help spell equations, right? I'm going to have you guys solve the trig equations for pi over 4. And then also, think about what you might do for trying to figure out what x and y would be for pi over 6 and pi over 3. And now in that case, I'll give you guys a hint. It would be similar to this way because you would also do a triangle, but I would recommend you guys think about 30, 60, 90 triangles. Again, another one of those fun little throwbacks from high school. So, and then next time we're going to go talk about these 2 more in depth. And then we're also going to talk about like what you could do, for instance, if you know like sine of theta equals 1, but you don't know what theta is, how you could go about solving for theta. Have a great day, everyone.